Welcome to ACI, the Network Made Simple learning series. In this video, we will cover Module 3, Configuring Logical Connectivity, Chapter 3, Routed Connectivity, L3 Outs. At this point, you should hopefully feel very confident about connecting pretty much anything to ACI. However, we are not done yet. Connecting external Layer 3 devices to ACI is key, and we will learn how to do that through what we call L3 Outs. As we have covered before, every time we connect anything to ACI, including an external Layer 3 device, we first configure the physical network, in this case an L3 domain, and then the associated logical network, which is the L3 out itself. L3 outs support static routing and can peer to other routing devices using BGP, EIGRP, and Ospf. One of the functions of an L3 out is to redistribute externally learned routes into ACI through the border leaf nodes. ACI automatically does so by running MPBGP inside ACI and using spines as route reflectors in order to distribute those routes to the rest of the leaf nodes. L3 outs are also in charge of advertising internal ACI networks, such as bridge domain subnets, to the outside world. Now, if you remember, we have two types of EPGs: regular EPGs, which have MAC addresses and IP addresses associated to them, and L3 out EPGs, which are also known as external EPGs, which have prefixes instead. The key part here is that inter-EPG communication needs a contract by default, and this applies to both regular EPGs as well as L3 out external EPGs. The reason for us to review this is because an L3 out is also in charge of classifying traffic into its corresponding external EPG and redistributing traffic to the corresponding tenant and VRF, in order to allow or deny traffic through contracts, whether that means from a regular EPG to a specific prefix within an L3 out external EPG, or even between two different L3 outs and their corresponding L3 out external EPGs. In today's scenario, we have the web servers in the web EPG trying to gain access to the internet through an existing ISR 3945 router. We will configure an L3 out using Ospf as a routing protocol. We will assign that L3 out to our leaf 101, which will perform as the border leaf on interface E115. And then we will assign every learned subnet from that connection to the L3 out EPG. As usual with ACI, there are multiple ways to configure an L3 out. In this case, we will take a look at the wizard, which is available on ACI 4.2 and later versions, and we will compare it to the step-by-step approach in case you're running an earlier version. Regardless of the method you use, there are 3 steps that you will need to follow. 1. You will have to create the L3 out. 2. We will assign such L3 out to a border leaf or leaf nodes. And 3. We will classify the prefixes we want into a specific L3 out external EPG so that we can later communicate those with other EPGs through a contract. Are you ready? Let's do it then. Our application profile has 2 EPGs, web and database, and if you remember, we want the servers in the web EPG to have internet access. If we go to vCenter, we can confirm that one of the web server's VMs running on VMware in the 1110/24 subnet cannot access the internet at this point. Let's fix that then. First, let's check the configuration on the existing ISR 3945 router, which is our current internet router. We can confirm that both the ISR router and leaf 101 are physically connected using interface G01 and E115 respectively. On the router side, an IP address part of the 2221.2221.2210/30 network has already been configured and Ospf is running as well. However, as we would expect, there are no Ospf neighbors at this point and the router cannot ping the other IP address of the segment, in this case .2, since I have not configured it on leaf 101 yet. Now, on the ACI side, within our tenant, we are currently running a single VRF and 2 bridge domains if you remember, one for each EPG, as we can see in the networking section. Let's start with the first step then, creating an L3 out using the wizard. Right-click on the L3 out folder, and then let's add a name to our L3 out. Then let's assign it to our VRF and select the L3 domain you want to use for this L3 out. In our case, the ISR 3945 domain. If you remember, we created this L3 domain as part of the physical network configuration in Module 2. So if you need to go back and remember a bit, feel free to do so. To finalize step 1, I'll specify the routing protocol I want to run, which in this case is Ospf on area 0. In our case, area 0 is a regular area, So we'll go ahead and select that. If you want to use static routing, simply leave everything unchecked. I'll show you how to add static routes later in this chapter. The second step is to assign this layer 3 out to our border leaf. We will be using interface 115 as a routed interface, so I'll just select this interface type and then move on. Keep in mind, you can also use sub-interfaces and SBIs as well as port channels, as you can see. Let's go ahead and select our leaf 101, add a router ID to it, assign interface 115 to our L3 out, and finally add the 2221.2221.22.1/30 IP address to it, and click Next. We can also modify our Ospf interface's specific properties. In this case, I will adjust the only Ospf policy I have, which is the default one, in order to set the network type to point-to-point so that it matches our ISR configuration. If you don't know the MTU value on the other router, you can also check the MTU ignore option, since as you may know, Ospf needs matching MTU on both ends. The last step will be to classify any learned prefixes into an L3 out external EPG so that we can later allow or deny communication to them through a contract. In this case, I will make it easy, and I will create an external EPG called all prefixes, indicating that any learned prefix over this connection will be assigned to this external EPG. In order to do so, I just need to leave the default EPG for all external networks checkbox enabled. If you want to assign a specific prefixes learned through this L3 out connection to different external EPGs, you can definitely do so. You just need to specify each subnet or subnets to belong to specific external EPG. Now, if we go to the ISR, we can now see the Ospf neighborhood established. Let's now verify what was created on the ACI side. Besides the main section where we can see the routing protocol configuration we just did, there are two main subsections in our Internet L3 out. First, the logical node profile folder, where you can verify your L3 out configuration in terms of the switch nodes where the routing protocol is deployed, as well as their IP addresses and interface level parameters. We can also see the Ospf neighbors and related information within this folder. We also have the external EPGs folder, where you can verify your configured prefix classification into the corresponding external EPGs. There are more functions you could configure and that we will not cover today, such as VRF leaking and route map controls, which may be particularly useful if you use the ACI fabric as a transit network between different L3 outs. What if I wanted to add a static route? Well, that's fairly easy. Just go to the logical node profile section, click on the configure node, and in the static route section, let's add a quad 0 static route pointing to the ISR IP address as next hop. You can also add advanced options to this route like IP SLA policies and object tracking if you'd like. Everything looks good at this point. If you remember, the web server's BD inside ACI is configured with the 1110 subnet. However, if we go to the ISR 3945 router, that route is not in the table yet, even after establishing Ospf connectivity. The reason for this is because ACI is a secure network. Therefore, if you want an L3 out to advertise your bridge domain subnets externally, you just need to go to the bridge domain subnet and change its default value to advertise externally. Then, we just have to associate the bridge domain to its corresponding L3 out, and we can now see that route now being correctly advertised to the ISR router. The next step for us would be, well, can I ping any of the web server's VMs? And of course not. Why? Because our L3 out EPG, which includes the prefix where I am pinging from, does not have a contract yet. Let's quickly correct that then by going to the application profile. Let's just drag and drop the L3 out icon and select the right L3 out external EPG, in our case the one that has all prefixes, and then let's add a contract allowing all traffic. If we go back to the ISR, we can now ping the VMs, and if we go to our web server VM, we now can access the internet successfully. As you now know, the non-border leaves inside the ACI fabric will receive those externally learned routes through MPBGP. We can verify the routing table on any leaf by issuing the show IP route command within your tenant's VRF. It is very common to configure regular L3 outs for multiple tenants in the common tenant, especially for internet access. However, keep in mind that tenant isolation will be broken once traffic leaves the ACI network. If you need to preserve tenant isolation once traffic leaves the ACI network, you can either configure VRF Lite between the border leaf and the external layer 3 device, or use other types of L3 outs within ACI, such as MPLS and segment routing L3 outs, and even Gulf L3 outs, which are configured at the spine layer. These two L3 out types can serve as more scalable options compared to VRF Lite for tenant isolation purposes between the ACI border leaf and the external layer 3 device. However, they are out of the scope of today's session. If you have ACI 4.1 or earlier versions, I will redo the layer 3 configuration a bit quicker this time using the step-by-step option. First, we go to the networking section and drag and drop the layer 3 icon into the VRF where you want to configure your L3 out. Add a name to it, the layer 3 domain, and then select Ospf. Then we'll add the node and router ID, and from here we can add our quad 0 static route. Then we'll add the interface, adjusting its Ospf policies to point-to-point and MTU ignore, and selecting E115 with its corresponding IP address. Lastly, we'll create our all prefixes external EPG, classifying all networks within it by specifying a prefix that matches everything. And we're done. From there, all you have to do is set your bridge domain subnet to advertise externally as we learned, assign the BD to the L3 out, and assign a contract between your layer 3 out external EPG and the web EPG as we did in the wizard-based scenario. You now know how to configure the same L3 out configuration using either the wizard or the step-by-step approach. As a summary, when connecting to external layer 3 devices, you need to configure two main things: the layer 3 out with the corresponding routing protocols or static route parameters, and the L3 out EPGs in order to classify prefixes into external EPGs. Even if a single route is learned, such as 0000/0 from a layer 3 out connection, you can still create your own external EPGs with more specific prefixes in case you need to classify policies separately for different networks. External routes get redistributed automatically through MPBGP into ACI. If you use BGP as the external routing protocol in your L3 out, the same autonomous system you configured initially for the whole ACI fabric will be used. As you would imagine, options like summarization are also available within ACI. Remember that bridge domains are not externally advertised by default until you explicitly adjust their parameters. And last, keep in mind that external EPGs also require contracts, especially if you want them to have communication with other regular EPGs or even other external EPGs when using ACI as a transit network.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.